So this is something that I just wanted you to see. Quadratic equations can give us height of an object. You know, think about it. If you take a ball and you throw it up in the air, what's it going to do? It's going to come back down, right? So as it goes up and comes down, it forms that parabola. If I ask you for the maximum or minimum, we know that's given by the vertex. The formula for height of an object is this equation. I would not expect you to memorize it, but we should know how to read it. So S of t is the height at a given point in time. T represents your time in seconds. V is your initial or your starting velocity. And h is your initial or starting height. So this, you might have seen it in a science class before. Physics, I know, usually uses this quite a bit. So you might have seen it in the past, and I think maybe even in Algebra 2, you might have seen it once or twice in a problem. I'm going to show you a couple different things with this. So obviously, tests or quizzes, we're only doing the things that we can do without a calculator. But you guys take the ACT, and there's sometimes questions that you can use your graphing calculator for certain things. So I wanted to show you a couple tricks on those today. So if you would grab a graphing calculator. A ball is thrown directly upward from an initial height of 192 feet with an initial velocity of 16 feet per second. Give a function that describes the height of the ball in terms of time t. So the formula that you would not have to memorize, negative 16t squared plus v sub 0t plus h sub 0. In our equation, s and t are going to stay, their height and time. We basically just have to plug in the values for v and h. What is v, my initial velocity? 16 feet per second, so that's 16t. What is h, my initial height? 182. So that's my equation. If you were starting on the ground, what would your height be? 0. Good. All right. After how many seconds does the projectile reach its maximum height? If I'm looking for when it hits its maximum height, what am I asking you to find? The vertex, right? It's going to go up and come back down. I'm looking for this vertex. How do we find a vertex? So my v is 16, so we get negative 16 over 2 times negative 16. So that gives me 1/2. What does 1/2 represent? That's the x, which in this case, maybe x wasn't the best variable. We're used to seeing x squareds right here, right? So it's our t. So if you wanted, you could even change this if it helps you understand, since our variable in this problem was t instead of x. So t is time, so it takes half a second to get to our maximum height. If I want to know what is the maximum height, what do we have to do?
Enter a half into the problem.
Yep. So we're going to, s is height, we need to find height at 1/2 second. Get 196. And what is my height measured in? Okay. So I was just asking for the x and y values of the vertex. The x gave me my seconds. When I plugged it in, I got my height. After how many seconds will it hit the ground? If it hits the ground, what's your height?
0.
0.
So, we could work this out if you remember from last year. We will solve these equations in the next chapter, but I also wanted to show you a couple things on your calculator. So, let's go to our calculators, and we're going to go to the y equals, and we're going to type in the original equation. So negative 16, you can't use t, you have to use x on these, so negative 16x squared.
Wait, what did you include?
I went to y equals, and make sure if there's anything there, you clear it out. So we get negative 16t squared, so x squared, plus 16x plus 192. I'm not doing what I want. Okay. Now, if I'm trying to find this on my calculator, we have to adjust the window a little bit. Mainly the y's. Right now, the highest point is 10, but we already know from our vertex what's the maximum height we're going to go to. 196. So if you want, you could change your y max to 200, just so it'll show us the whole graph. Okay, this is showing us I think I have a typo on mine I need to fix real quick.
I can see the graph.
You hit the graph button. So it should look like this. Okay. If you wanted to find this vertex, let's say you're on the ACT and you forgot, your calculator can do it for you. If you hit second and this trace button, this is all the different stuff it can find. If I'm finding that vertex, what would that be?
Maximum.
A maximum, number 4. Now, you just have to tell your calculator where to start and stop looking, because this graph goes on forever. We're just only looking at part of it. So it'll prompt you with questions. It's going to say left bound. All you have to do is make sure your cursor is to the left of the point you want. Okay, it doesn't matter how far to the left, it just has to be to the left. And hit enter. That's saying start looking here. Right bound says stop looking here. So you just have to go to the right of your point and hit enter. And then it asks you for a guess. You really don't even need that. Just hit enter one more time. And what does it tell me? Yeah, 0.4999999. So that's giving me 0.5 and the 196. Is that what we got for our vertex? So your calculator can find that for you.
No.
No. Huh? I believe it can. Then I want to know when it hits the ground. If it hits the ground, what's our height? Where is it? 0. So if we go back to the second trace, which one do you think we want? A 0, number 2. Now the calculator asks you questions. Left bound. Which point am I looking for on my graph?
0.
When it's 0. Would I want this one or the second one? So a 0 is another way of saying when it hits the x-axis, right? When my height is 0. These are the 2 places where it hits the x-axis, right? But keep in mind, your x represents time. This one is negative. Can time be negative? No. So I'm trying to find this point. So you have to tell your calculator left bound. You just have to be somewhere to the left of that point and hit enter, just saying start looking here. Right bound, you just have to go to the right of that point. So we have to go past it, use our right arrow, hit enter, and then enter our final time. And it tells us what's the 0? So it hits the ground after 4 seconds.
For show.
am I going to make you do this on a test or quiz? No, this is bonus information, how to use your calculator to help you out on ACT with some tricks. All right, any questions there?
Now we want to.
Let's try another one. A toy rocket is launched straight up from the ground with an initial velocity of 200 feet per second. So I want my height.
200 FPS.
So my formula is negative 16t squared plus v sub 0t plus h sub 0. What is my v sub 0?
What do you say?
My v sub 0, initial velocity.
200 feet per second.
What is my beginning height?
0.
0. So do I even need that?
No.
B. Determine the time at which the rocket reaches its maximum height and the maximum height in feet. So what do we do?
Opposite of B.
Opposite of b over 2a. So x equals, in this case our x is t. Opposite of b over 2a. That's the opposite of 200 over 2 times negative 16. So I get 6.25, what would my units be? Seconds. All right, then we found the time. How do we find our maximum height?
Plug in 6.2. You could have also done that on the calculator. You'll just have to adjust it so you can see the whole thing. Part C, after how many seconds will it hit the ground? So if it hits the ground, what's our height? Okay. In a minute, I'm going to show you how to solve these equations by hand, or you might remember from last year. If you were choosing to use your calculator, since we're trying to practice that trick, we enter our equation, negative 16, we have to use x squared plus 200x. And if we just hit graph, am I seeing everything? No. So you can have a couple different options. You can go and adjust your window if you wanted. So it looks like my x's need to be, I need to see more, so I might make my x max 20. My y, we don't even have to see the top here because I'm trying to find when it hits the ground. So if I just make my x max 20, it would show me what I needed. We're looking for this point here when it hits the ground. So what do? Second trace, we're looking for a 0. Left bound, so I just have to have somewhere to the left of my point. Can't really see my cursor here. So I'm just going to keep using this arrow until I can see. It does give you the coordinates and tell you where you're at too. Alright, so I finally saw it. I can hit enter. Right bound, we just have to go to the right of it, hit enter, and one more time for a guess. And what did you guys get? hits the ground after 12.5 seconds. Again, do I expect you to do that? No, this is bonus knowledge to help you out. All right, so we have a couple things we're going to do. We're going to pause now. I'm going to give you a few minutes to finish that question on the homework. We're going to grade that homework and we'll do some more notes in just a bit. So we've talked about the graphs with quadratics. Next piece, we are solving equations, and we're going to talk about a lot of different strategies for that. Today, we're just going to start in with the last few minutes that we have. I'm using the zero factor property, which tells us if you have two numbers multiplied together that equals 0, then one of those numbers has to be 0. So if we can get things so it's a multiplication problem equal to 0, then we can get a solution. The other thing that I want to note is repeated solutions are called multiplicities. So, multiplicity is when you have the same answer more than once. And we will look at problems where that happens and how we write it. But the multiplicity is how many times the solution occurs. So, let's say I asked you to solve each of these equations. The zero factor property says it has to be multiplied together equal to 0. So the first thing I'm going to do is get it equal to 0. I prefer to always keep my x squared positive. So to do that, you have to add over the x and subtract the 12. Yeah, x squared plus x minus 12 equals 0. Then we know how to factor that. X squared plus x minus 12. How does that factor?
X plus 4, x minus 3.
So we have things multiplied equal to 0. So you say each equation equal to 0. So we get x to equal -4 and +3. I don't care if you write x equals, or if you want, you can write them in a solution set. Just don't do parentheses. That looks like an interval where it's everything between them. So either x equals or put it in the solution set. You can always check these if you plug it in. -4 squared is 16. 12 minus -4 is 16. That works. I put in a 3. 3 squared is 9. 12 minus 3 is 9. So it works. What do we do for b? We don't want to divide because we lose it, but let's factor it out. We only have two terms, they both have an x, so if we take out that x. So again, we have two things multiplied equals 0. So if we set each one to 0, we get x to be 0 and 9. Any questions so far? Let's do 2 more and then we'll stop for today.
So on C, it's already equal to 0. I need two things that multiply to 9 and add to -6. When you set that equal to 0, they're the same, we just get x equals 3, but how many times was that a solution?
Twice.
Twice for each parenthesis. So we write that as 3m for multiplicity and 2. Tells me 3 is a solution 2 times. In terms of just like finding a solution, it doesn't make a big difference. But later on when we get to graphing a lot of things, that multiplicity has an important meaning. So we don't want to just get in the habit of ignoring it. Let's go ahead and just start writing it down so we acknowledge it. So my actual answer is 3, but if I asked for the multiplicity, it was a solution 2 times. Remember, these are quadratics. How many solutions am I getting on every problem? 2. It's x to the second, you're going to get 2 answers. Here we just got the same number for both answers. And D, what would we do? X squared minus 12x plus 36. What multiplies to 36? Then what do we do? Divide our 4 back. So that reduces to 3 over 2, so we get 2x minus 3 times 2x minus 3. Okay, if you set that equal to 0, what do we get?
2x plus 3.
B. X is 3 over 2, but that was for both of them, so it's a multiplicity of 2. All right. Any questions there? Okay. We will pick up with this tomorrow. No homework tonight.